We're now going to graph the trigonometric functions using something called the 5-key point method. To use this method requires that you understand what the amplitude is and what the period of the trigonometric functions is as well. In addition, you need to understand exactly how the graphs of y equals sine of x and y equals cosine of x behave. So we're going to graph y equals -4 sine of x. For starters, we should notice that the amplitude of this particular function is the absolute value of -4, or 4. That means that the y values are going to oscillate between -4 and 4. We also should notice that the period t of this particular function is 2 pi radians because omega, the coefficient on x, is 1. That means that it's going to take exactly 2 pi radians to draw one complete cycle of the graph. Let's say that a cycle is going to begin at x equals 0 and a cycle is going to end at x equals 2 pi. If we take that interval from 0 to 2 pi, we can divide it into 4 subintervals. The 4 subintervals are going to be of length equal to the period divided by 4. Well, our period is 2 pi, divide that by 4, and we get pi over 2. So my first subinterval is going to begin at 0, because that's where one cycle begins, and then it's going to end at pi over 2. My next subinterval begins at x is pi over 2 and ends at pi. My next subinterval begins at pi and ends at 3 pi over 2. And my last subinterval begins at 3 pi over 2 and ends at 2 pi. Now what's key in understanding how to work the 5-key point method is to remember the key points on the graph of y equals sine of x. They are 0, 0, starting at the origin. Then, when x is pi over 2, the sine function is 1. When x is pi, the sine function is 0. When x is 3 pi over 2, the sine function is -1. And when x is 2 pi, the sine function is 0. The x-coordinates corresponding to these key points correspond to the endpoints in these intervals. So for example, my first x-coordinate is at 0 for my key points. My next key point has an x-coordinate of pi over 2. My next key point has an x-coordinate of pi. My next key point has an x-coordinate of 3 pi over 2. And my last key point has an x-coordinate of 2 pi. Then, understanding how the graph of y equals sine of x behaves, what we're going to do is find the corresponding y coordinates on the graph of y equals sine of x. What we have to understand here, though, is that we're graphing y equals -4 sine of x. So, what does the -4 do? Well, we know from the transformation study of graphing the trigonometric functions that this is going to cause a reflection about the x-axis, and the 4 is going to cause a stretch by a factor of 4. So, instead of 1 being the y-coordinate as a key point, it's actually going to be 1 times -4, or -4. Then we're going to be back to 0, then to 4, and then back to 0. So as far as my key points on this graph go, they are going to be the x-coordinate is 0, the y-coordinate is 0. Then at pi over 2, my y-coordinate is going to be -4. Then at pi, my y-coordinate is 0. At 3 pi over 2, my y-coordinate is 4. And then I'm back to 2 pi comma 0. So I draw a Cartesian plane. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. Pi over 2, pi, 3 pi over 2, 2 pi, and then I'm going to keep going. 5 pi over 2, 3 pi, And then I'll go in the negative direction, negative pi over 2, negative pi, etc. So let me start labeling or scaling the x-axis. And now I can go ahead and plot my key points. 0, 0, pi over 2, negative 4, pi 0, 3 pi over 2, positive 4, and 2 pi. Knowing what the graph of y equals sine of x looks like, I get that. Now, knowing the periodicity of the sine function and the period is 2 pi, I can keep going plotting key points. This point would be 5 pi over 2, comma negative 4, and then back to 3 pi, comma 0, so on and so forth. Or I could go in the negative direction. Negative pi over 2, comma, positive 4, and then back to negative pi, so on and so forth, and I have a complete graph.